Welcome to the Crazy Hat Chemist. So today, we are going to be doing electron configurations and orbital box diagrams worksheet number 1. There's a front, there's a back to this with a total of 9 problems. And what we're going to be doing is we're going to be writing out the electron configuration. We're going to be doing the orbital box diagram, and we're going to determine the number of valence electrons. So I'm hoping that you're having a great day. In order for us to get started on this, we need to pull out a periodic table, and we're going to label our periodic table, and that will assist us in our entire journey through this process here. So without further ado, let's pull out a periodic table and let's proceed on forward. So what we're going to do is we are going to label up this periodic table. And so in order to do that, I'm going to zoom on out here so that we can see this entire periodic table. I'm using this specific periodic table for this activity. It's entirely up to you which periodic table you want to use, but this is the one of my choosing. All right. So what we're going to do is we're going to do some specific labeling here that will be greatly important to answer all the problems on that worksheet. And I'm going to be referring back to this periodic table. The colors of which I'm going to highlight here mean nothing. They're just to distinguish the different groups and sections on the periodic table that will be important. So here we go with our first section. Our first section here is right here. And these are group 1 and group 2 elements, and these will be S as in sharp type orbitals. Okay, the other one that belongs in the same category is helium. So this is the only time that helium is not where it should be, and it should be up over here with helium right being there, if you will. So I'm going to use another color. Again, the colors are unimportant here. What is important certainly is the grouping of these. So this next grouping is right here. And this is going to be a different labeling other than S here. And there we go. And these will be P. Okay, so P. All right, perfect. And that is P for principal. And then what we got is we have another section of the periodic table right over here in the middle. And that's going to be right over here like this. I'm going to highlight this section of the periodic table. Perfect. And these are going to be Ds. So this section here are the Ds, right, for diffuse. And then our final and last section of the periodic table, which you could have guessed is this bottom section here. Okay, and that here is F for fundamental. So F for fundamental, just like that. Perfect. I'm going to highlight these just a little bit more with a black Sharpie so that you can see these letters here a little bit better. This is S as in sharp, P as in principal, D as in diffuse, and F as in fundamental. And these are the types of orbitals in which we'll be discussing here. Now, I'm going to do a few more things here. One of the other items that we're going to be doing here is highlighting as far as categories is I am going to write down the number of valence electrons within these groups. So we're going to do group 1 and group 2. That's 2 valence electrons, 1 and 2 valence electrons respectively. This is 3 and 4 valence electrons, 5 and 6 and 7 and then 8. I will draw a line through helium, being that helium does not have 8 valence electrons. Now, I'm going to highlight another section here of the periodic table so that you can see it here, and that will be right here like this. Perfect. No, very good, very good. Excellent. All right, and I'm going to add one more thing to this here. So zooming on out just a little bit so you can see everything here. Perfect. All right, excellent. That looks like a boot to me. Well, it's kind of a, poor looking boot, but it looks like a boot. And if you are in the boot, the number of valence electrons of which you would have would be, wait for it, how many boots do you wear? That's right, 2. Okay. 2 valence electrons. All right. And so then we're going to do one other thing here. We're going to do some highlighting of some other numbers in addition to this. And we're going to choose another color here. I'm going to choose green. I'm going to circle some numbers, and that would be this 1, this 2, this 3, 4, 5, 6, and 7. But I'm going to add in some numbers here that correspond to these numbers, and that would be a 3 right here. Would be a 4 here and a 5 here, a 6 here. I want you to note that these numbers within the D's are 1 less than the period. The periods are horizontal sections on the periodic table. Groups are vertical columns on the periodic table. So if it's in period 4, then this is a 3. If it's period 5, it's a 4. If it's period 6, it's a 5. Period 7 is a 6. And then the F's are actually inserted into the D's. So this would be a 4 and this would be a 5 right there. Okay. So those are going to be really important. I'm going to do one other thing here, and we're going to fold the periodic table. So just as some helpful information and hints, what grade do you not want to get in a chemistry class? Well, that's right, an F. So what we're going to do is we're going to fold out the F's so that we don't have the F's anymore. Right, so here we go. We're folding out the F's. Okay, perfect. And now you're left with S and P's. Well, what other grade do you not want to get? D's. That's right. So you don't want to get a D in a chemistry class. And so how do we get rid of D's? Well, real simply, we just fold out the D's. Again, you earn your grade in chemistry. So how do you earn a good grade? Well, you just have to work hard for it, and then you earn the grade that you deserve. Okay. So hopefully you don't deserve a D. So right here, I folded in the D's, and what we're going to do is fold out the D's. So we're going to get rid of the D's by pulling this back, and here we go. Now, what I have instead of just showing up the D's, now I have, what do you see here? Here we go. That's right. So what I have here is the satisfactory passing grades in a chemistry class. You should see that the S and P type orbitals go with these numbers that I've circled in green on the left-hand side. So this is period 1, period 2, period 3, period 4, period 5, period 6, and period 7. And then you should see that the G's are actually 1 less than the period, and then the F's are 1 less than the D's. All right? Fantastic. So that's what we have for our periodic table. And let's put our little weights on here so that we can use these here to hold everything down. And that's what our periodic table looks like. So that is our perfect periodic table when we are talking about writing electron configurations. All right, so now what we need to do is actually do some electron configurations. That's the whole goal of this little activity and worksheet here today. So now we're going to pull out the worksheet. We're going to keep our handout here of our periodic table that we have labeled. And so we're going to refer back to this periodic table frequently. So here we go. So electron configurations and orbital box diagrams, worksheet number 1. I'm going to zoom in on this so that you can see something. So we're going to look at this number right here. That number is a 4. Now, I am using part of the standard nuclear notation, which is A, X, and Z. So that 4 is the Z, and the Z is the atomic number. And the atomic number is equal to the number of protons. And the periodic table is principally organized according to protons. So what I need to do is I need to find element number 4, which is beryllium. It has the symbol of Be, so I should verify that. So what I'm going to do is I'm going to go over to my periodic table, and I'm going to look at the section where beryllium is located. And here is beryllium. It is most certainly element number 4. So that was really easy to find, and it is a symbol of Be, and it is beryllium. All right, fantastic. So now what we need to do is we need to zoom this on out a little bit so that we see our entire periodic table. I'm going to zoom in and just the section that we are going to use for this particular element. So you can see part of my periodic table. It's the S's, the D's, and the P's. The F's are kind of down here at the very bottom. We're not going to be using that at this moment in time. So we're trying to get the electron configuration of beryllium. But what we're going to do is we're going to use the noble gas notation. So in order to use the noble gas notation, we need to figure out what are the noble gases. The noble gases are slammed on the right-hand side of our periodic table. So I am highlighting the noble gases in yellow right here. So these are the noble gases highlighted in yellow on the far right-hand side of our periodic table. So we're going to be using the noble gas notation here. So what we're going to do is we're going to find our element of choice. That's what we want. Okay, move these up just a little bit here. We're going to find our element, and then we are going to go up one period. So it's almost like you're going up one floor, and then we are going to slam this all the way to the right-hand side. We're going to find the noble gas, and in this particular case, it is going to be helium. So we are going to write down HE in brackets. So we're going to write HE in brackets. Now notice that this is H, capital H, and a lowercase e, just like it says on the periodic table. You cannot use a capital H and a capital E. That does not work. That is not helium. Okay, that is, I have no idea what that is. All right. And so now what we're going to do is we have, by just writing HE in brackets, we have gone up to element number 2. So we need to count to 3 and then finally 4. Okay, so we're going to put our piece of paper back here again, and we have helium right there in brackets. Now we are going to do 3 and 4. Well, 3 and 4 are in floor number 2, if you will. So I'm going to write down a 2. What type of orbital is 3 and 4, or are 3 and 4 in? It's an S-type orbital. So I'm going to write down S. And now I'm going to count the number of electrons within this. That's 2s1 and 2. So I'm going to write 2s2, just like that. Perfect. All right. Now what we're going to do is we're going to simulate this same thing here by doing an orbital box diagram. This down here is going to be our orbital box diagram. We have HE in the brackets, just like before. We're going to label this as 2s, just like what we had right here. We do not put a number up here, so it's absent of a number here. This 2 is the number of electrons. There are 2 electrons in this energy level of 2 and this type of orbital, and they're represented in an orbital box diagram as arrows. The first arrow is up, the second arrow is down. And there is a set of rules. That's the off-bow principle, Pauli exclusion principle, and Hund's rule are the set of rules in which electrons are placed in atoms. So those are going to be very important. We're not discussing those right now. The next part that we're going to do to finish up this problem is the number of valence electrons. I have written that in red up at the top. So there's beryllium. How many valence electrons? 2. So this will be 2 valence electrons for beryllium. One easy way to look at this is it's the largest principal quantum number, S and P, and there are those 2 valence electrons written right there. Perfect. Cool. All right, so now what we need to do is do the next problem. So I'm going to try to move along a little bit faster so that you are able to do this along with me here, but at the same time, get it and understand it. All right, fantastic. All right, so here we go. Our next element that we're going to be doing is boron. And so I'm going to highlight that. The number for boron is element number 5. It's a capital B and it's a boron. So I'm going to find element number 5. That's right here. That's capital B and that's boron. So that's what I'm going to do. So just like before, I'm going to write the electron configuration. So I'm going to go up one period, slam it to the far right. That's going to be helium. I'm going to write down helium in brackets here. So it's HE in brackets, just like that. Fantastic. All right. Now I have counted up to 2 because I wrote helium in brackets. The next number is 3 and 4. And then I finally need to count to 5. So I'm going to fold up my periodic table like what we had before, folding out the F's and then also folding out the D's. And so this is what remains of my periodic table. Okay, so I have helium, and now I'm going to do 3, 4, and 5. So it's going to be a 2s, 1, 2. Then there's a break in the periodic table. So you see that break right there, that break in the periodic table. I cannot continue with the S's. So I'm going to have to write that down. So that's 2s2. And you can recognize that that is the electron configuration for beryllium that we just did a moment ago. But we're not going to end there. Then we're going to write 2 and then a P, and then it will be 1 because I'm just counting up to boron. So that's a 1 right there. So it's going to be 2p1. I'm going to write that down. 2p1. Perfect. So that is the electron configuration for boron. I'm going to copy the same kind of thing here. I'm going to write helium in that right there like that in the brackets. Then I'm going to label this as 2s and 2p. Remember, there are no numbers up there. There's 2 electrons here. That's an up and that's a down. And then there's 1 electron here and that's an up. The first electron is always up. The number of valence electrons in boron is the number at the top of the group, and it's boron right there. And so the number at the top of the group is a 3. So how many valence electrons? 3. So I'm going to write that down, 3. And you can do that by adding up the largest quantum number of S and P. That's 2 and 2. And you can add up these two numbers and get that same 3 right there. Cool. This is a great way to do this, folks. This is awesome. So our next element that we're going to do here is going to be nitrogen. So here is nitrogen, and that is element number 7. It's N, capital N. It is nitrogen. So I need to find nitrogen on my periodic table. It is element number 7. That's capital N, and that is nitrogen. I'm just verifying that that is the element that I'm looking for. Okay, I am going to find nitrogen. I'm going to go up 1 floor. I'm going to slam it to the right-hand side. That's helium. That's counting up to number 2, just like what we did before. So I'm going to write helium in brackets just like that. And that is counting up to 2. Now I'm going to do 3, 4, 5, 6, and 7. To do 3 and 4, that is going to be in floor number 2. It's an S-type orbital. It's 1, 2. And then I'm going to have to stop because, again, the periodic table breaks. So I'm going to write down 2s2. So that will be 2s2. There we go. Perfect. Now I'm going to continue on here. So I'm going to continue on, but with that break here, you should see that the same horizontal section here is in floor number 2. So it's going to be a 2 and a P, and then it's 1, 2, and 3. 2P, 1, 2, 3. All right, so I'm going to write that down, and that will be 2p and 3. I'm going to simulate this same electron configuration that I have here in the orbital box diagram. That's helium in the brackets. This is 2s. This is 2p. And then I'm going to follow the rules of Hund's rule and Pauli exclusion principle, and that is up and down, and then 1 and 2 and 3. That's unpaired electrons, the maximum multiplicity, as they call it. Okay, the number of valence electrons, the largest quantum number, S and P, I'm going to add up these two numbers, and that's a 5. And I'm going to just verify that with that number that's on the periodic table above nitrogen. There's nitrogen. Oh my gosh, it is a 5. So I am rocking and rolling, and I am good. All right, next element here. Next element is right here, and that is element number 9. That's a capital F, and that is for fluorine. So I'm going to find element number 9 on my periodic table. That is element number 9, and that is F, and that is fluorine. Perfect. So I'm going to do the electron configuration, and then I'm going to do the orbital box diagram for fluorine. All right, perfect. So there's fluorine, and let's see. I'm going to find fluorine. I'm going to go up 1 period, slam it to the far right. I'm going to write helium. So that's what I'm going to write right here. I'm going to write helium in brackets, just like I've been doing before. And then that's counting up to number 2. After that, I'm going to count 3, 4, 5, 6, 7, 8, and finally 9. So to do 3 and 4, it's a 2 and an S and a 1, 2. 2S, 1, 2. I'm going to write that down because there's a break in the periodic table and I can't continue because the rest of them are P's. And so I'm going to write down 2s2. Perfect, just like that. I'm going to continue, since it's in the same horizontal section, that would be a 2 and a P, 2P, 1, 2, 3, 4, 5. That's 2P, 1, 2, 3, 4, 5. I'm going to write that down, and then I will be done with fluorine, 2P5. I'm going to simulate this same thing here. This is helium right here in the brackets. This is a 2S, this is a 2P, and the electrons are placed in the following order. That is an up, that is a down, that's an up, that's an up, that's an up, that's 3 of the 5, and that's 4 of the 5, and 5 of the 5. Okay, the number of valence electrons is the 2 plus the 5 because it's the same principal quantum number, so that's a total of 7. And let's just verify that that is the case. If I look at my periodic table, I should find fluorine, and the number up above is a 7, and yes, 7 valence electrons for fluorine. Perfect. So just a quick little note here. I am the Crazy Hat Chemist, and you are watching the Crazy Hat Chemist here on YouTube, and I would appreciate if you were to like and subscribe, at least subscribe, tell all your friends about this is the place where you learn how to do real chemistry. All right, the next element here is going to be element number 11, and that is element number 11, which is Na, of which, of course, is sodium. So I'm going to find that on my periodic table, and that is right here, number 11, that's Na, that's sodium. So I verified that on my periodic table. Awesome. Now what we're going to do is find, so we found sodium. So we're going to do the same pattern that we've been doing thus far, and that's we're going to go up one floor and slam it to the far right. Now we're going to use a new noble gas that we haven't been using before because sodium is one floor lower than what we've been using. So it's up one floor, over to the right, and that is neon. So I'm going to write Ne in brackets. Awesome, just like that. Then it's going to be a 3 and an S and then 1, 3S1, because I'm stopping right there. That's sodium. So it's 3S1. I'm going to simulate this same thing here. Oh, I'm going to have neon right here. I'm going to have a 3S, and there's 1 electron, just like that. Okay, I'm going to look on my periodic table. I'm going to find sodium, and the number up above is the number of valence electrons, and that's 1. And so I'm going to write down the number of valence electrons, that's 1, and that does correspond to that as well. Largest principal quantum number, S and P. Perfect. We are moving right down the road here. So let's see if we can do the next elements, electron configuration and orbital box diagram. That is element number 14. That's Si for silicon. Let's find that on our periodic table. So that is element number 14. That's Si for silicon. Beautiful. Okay, so now what we need to do is we need to find that element, 14. We're going to go up one floor, slam it to the far right. That's going to be neon again. So I'm going to write down neon and E in brackets. Again, that's brackets, not parentheses. That's a capital E, capital N, lowercase e. Thank you very much. That's counting up to number 10. Now I'm going to do 11, 12, 13, and finally 14. Okay, so it's going to be a 3S1, 2. And remember, there's a break right there, so that's when I stop. So 3S2, 3S2. That's not read as 3S squared. I know your math teacher might think so, but a chemistry teacher would tell you 3S2. That's how we read that. So we've gone to 3S1, 2. We need to keep on counting. It's in the same floor, which is the third floor. It's P, so 3P, and then 1, 2. And that would get me to silicone. That is 3P2. Perfect. The number right above the silicone is a 4. That tells you the number of valence electrons in silicone. That is 4. Perfect. It's the largest principal quantum number, 3 S's and P's, and I should sum up those to get that 4. That's the other way of doing it. This is neon in brackets. This is a 3S. This is a 3P. And we're going to go up and then down, and then we're going to go up, and then we're going to go up again, just like that. So now we got the electron configuration for silicon. Beautiful. You guys are doing a fantastic job. Okay, so hang on. We only have 3 more problems to do. This is element number 16. It's capital S for sulfur. Let's find that. That is element number 16, capital S for sulfur. Just found that. That seems pretty simple here. Okay. All right, so now what we need to do is find the noble gas that is prior to this element here. The noble gas that is prior to sulfur is what? We're going to go up one floor, slam it to the far right, and that is neon, just like it was before. So we got neon in brackets, just like that. And we have counted up to number 10. Now we're going to do 11, 12, 13, 14, 15, and finally 16. So that's going to be a 3 and an S12, 3S12. Write that down, 3S2. Okay, we're going to continue because there's this break right there. There's the break, and then it's going to be still a 3 and a P and a 3P, 1, 2, 3, 4. 3P, 1, 2, 3, 4. Write that down. 3P4. Perfect. Largest principal quantum number 3 and 3, S and P, 2 and 4. I sum these two numbers up and I get 6. Let's verify that. Sulfur is 6 on the periodic table. Perfect. I'm going to do my orbital box diagram, and that is neon here in the brackets. That's a 3s, that's a 3p, and I've got an up and I got a down. This is an up, and an up for 3, and the fourth one is a down one there. Perfect. Beautiful. You got that? Now we're going to do our next element, which is vanadium, for element number 23, capital V for victory, vanadium. So let's find this element. So it's number 23, and I don't see it in the section of which I'm in. So then I'm going to have to open up my periodic table a bit here to find vanadium. Okay, so let's get everything here on our periodic table. Perfect. So vanadium is element number 23. That's capital V for vanadium. So I've just found it. Now what I need to do is I'm going to go up one floor, slam it to the far right. That's going to be argon. So a new noble gas that I haven't been doing. So that's vanadium. I'll do that again. We're going to go up one floor and slam it to the far right. That's going to be argon. So I'm going to write argon in brackets. That's AR in brackets there, just like that. Beautiful. So when I write down argon, that means I've counted up to 18. Now I'm going to do 19, 20, 21, 22, and finally 23. 19 and 20, that's in level 4, and it's an S, so it's 4S12, 4S12. I'm going to write that down. That would be 4S2, just like that. Then I'm going to do 21, 22, and 23. 21, 22, and 23 are in the Ds, and it's a 3. See that 3 right there? It's 1 less than the period, so it's going to be a 3D. That's a 3D, 3D, 1, 2, and 3. 3D, 1, 2, 3. 3D, 3. Okay, beautiful. So it just so happens that vanadium is in the boot. So how many valence electrons with the boot? That is 2. Okay, and that is 2 valence electrons. And how do I find that? By doing it this other way. You can find the largest principal quantum number, which in this case is a 4, not that 3. That's why I'm not going to add these up, whereas all the previous ones, it had the same number. So it's those 2 that go over there like that. The orbital box notation, that's going to be AR, and that's a 4s and a 3d. It's 4s 1 and 2, and 3d 1, 2, and 3. Beautiful. We have one more to do. That's number 9, number 9, number 9. Hopefully someone's got that joke right there. That is number 33. That's AS for arsenic. So let's find that element on the periodic table. And that is element number 33. That's AS for arsenic. So I need to get all the way to arsenic. So again, we're going to do this just like what we did before. There's our element of choice. That's what we're hunting down. That's what we're going for. We're going to go up one period, slam it to the far right. That's going to be argon. So I'm going to write down AR as my noble gas. So that's AR in brackets as my noble gas. I have counted up to 18. Now I'm going to do 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and finally 33. So 19 and 20 are in floor 4, S-type orbital. So it's 4s12, 4s2. 4s2, just like that. Beautiful. And then it's 3d, 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to stop there because there's this break here between the D's and the P's. So that's a 3D10. 3D and a 10. And then I'm going to refold this periodic table so that you understand, just like what we've been doing before with some of the other ones of boron, nitrogen, fluorine, silicon, and sulfur, the S's and P's stay with the period. So I've already counted up to 30. So now I need to do 31, 32, and 33. That's in level 4, but it's a P. So it's 4P, 1, 2, 3. So it's a 4P and a 3. Okay, now I'm going to look over here on my periodic table. I'm going to find arsenic. What's above that is a number 5. That's 5 valence electrons for arsenic, 5 valence electrons. And remember, it's the largest principal quantum number, which is 4s. And I can sum these two numbers up. 2 plus 3, that's 5. And that adds up there. Okay, what we're going to do right now is we're going to do the orbital box diagram of this same thing, and that is argon, and that's 4s. This is 3d. This is 4p. This is 1 and 2. This is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's completely filled. This is 4p3. So that's 1 and 2 and 3. There we go. All right, so I believe that's it for this worksheet. We've done a front, we've done a back. I'm just gonna place out here the periodic table as a real quick little summary and zoom on out here so that you see this whole thing right there. There's our periodic table that we have labeled and we're using. This is the front of the worksheet, which is all of them right there on the front. And that's 1 through 4. And then here is the second part of this worksheet. And let me zoom on out just a little bit more to get all that in there. So you got all that. And that is the second part. And that's all of it. Again, I am the crazy hat chemist. That's why it's crazy, crazy, crazy stuff over here. I'm the crazy hat chemist. Please, if you are learning chemistry, if you're learning from my videos, I would greatly appreciate it if you give me a thumbs up on that video, give me a like, and then please subscribe. And please tell your friends in their chemistry class that you need to be watching my videos. All right, I'll see you next time and have a fantastic day. Signing out for now. Bye now.